Chile, north of Santiago. I got probably 30 gigabytes worth of plant photos, but I'm only, of course, going to share a few of them. So I'll share a bit of this, the Altiplano, the higher elevation area east of Arica, like right on the border with Peru. And then I'll share some stuff from the fog deserts. And then if we have time, I'll share some of the New Caledonia stuff. Everything here is dictated by the fog. Everything, you know, it's the Atacama is the driest desert on earth, but it's not very hot. It only gets maybe up to about 90 degrees Fahrenheit, and most days it's not even that. I mean, I guess it depends when you're there, but it's not a really hot desert. So a lot of plants that do well in the Atacama just melt if you take them to an actual hot desert like Phoenix, which is what, you know, a lot of the cactus aficionados have experienced with genera like Copiapoa and Eulychnia, which are two cacti genera down there. So that kind of surprised me. I thought it was going to be a hot desert. I was kind of blown away to see that it's basically, because of those cold ocean currents that come up from the south, it's somewhat analogous but much drier to our Mediterranean climate and the climate we have in Baja California. So starting there, I'll just show you where we went. We went east from Arica up, basically ascending in elevation to about 15,000 feet. So the next photos are starting at about roughly 1,000 to 2,000 feet. And I can't emphasize enough how barren this habitat was. It was just super, super barren, super dry. You know, they'll go 8 to 20 years in between rainfall events. And in between, almost all the precipitation they're getting is strictly in the form of fog blowing in from the Pacific Ocean. So starting there, we're heading east right now. So this is what you're looking out on is just completely barren. The geology is volcanic, of course, too. It's mostly andesite because you've got that subduction zone right off the coast. You've got the Nazca Plate subducting beneath the South American plate. So this is, you know, east of Arica, maybe a couple miles. This is what it looks like. It's just these strips of some sort of plant life. We couldn't tell from far away, and just volcanic rock. And then getting closer to what these strips were, I realized they're a species of Tilansia. This is Tilansia marconi. Now, of course, the roots in Tilansia, in almost all Tilansia, are strictly for anchoring. They just kind of act as a holdfast. Where Tilansia takes almost all of its moisture in is due to the trichomes on its leaf blades. So this is Tilansia marconi. There were two species here. You can see the trichomes up close. They've got these they're called Peltate Trichomes. So it's like a shield, you know, held up by a little strand, and that basically helps trap water, and that's what does almost all of the nutrient and water uptake. And of course, there's not going to be much nutrients here. It's a barren desert, and you're just taking in water vapor. And so the temperatures here, again, are not that hot. I mean, when we were here, it was like 60 or 70 degrees. It's just very, very dry. It's probably 70 degrees. This is about 2,000 or 3,000 feet in elevation. There's a flower. You can see the bracts. These are, of course, a monocot. They're in the order like scales. They're really weird, but you could see they're so efficient. It's incredibly efficient at trapping moisture. And I mean, it's the only plant that you see for miles. It's the only thing growing there. So that's Talanzia marconi. And then this species is Talanzia Lanbeckii. And it's a little bit more filamentous. It looks more kind of like a beard. And, you know, shorter leaf blades as well. But just extremely pilose, extremely tomentose. Just a really hairy plant. And again, that's to trap moisture, but also to, you know, mitigate the intensity of some of the ultraviolet light, some of those UV rays. There's the flowers. They're spent. They're old flowers, but you can see the ovary developing in there. Little seed capsule. There's a close-up of Lanbeckii. So moving inland, you can see there's more foliage now. That's only because there was a creek running through here, a creek draining the snow off the Andes Mountains about 20 miles to the east. So as the crow flies, these mountains were not that far, 20, 30, 40 miles, but within that small amount of distance, relatively small amount of distance, there was an enormous elevation gain. We ended up going up to about 15,000 feet. This is at about 4,000 feet. This is Equisetum Gigantium. It's basically a giant horsetail, and some of them were upwards of, 7, 8 feet tall. And there you can see the habitat. You've still got that kind of volcanic, basically volcanic deposits, and mostly andesite, which of course was named after the Andes mountain chains. Is a, intermediate silica. It's intermediate on the extrusive igneous rock spectrum. So there's silica and then a modicum of magnesium and iron in there too. But the way this stuff erodes, you can see the talus piles right here. Very, very steep and very, very unstable terrain, which poses a hazard to someone like me who tends to be a jackass willing to risk his life to get a photograph of a plant. So there's a turkey vulture. Right there you could see how barren that entire that entire landscape. Not a single plant, nowhere to be seen. This guy was just sunning himself, thermoregulating. This is in the morning. He's trying to warm up. So moving on up, now we're at an elevation of 6,500 feet. Starting to see a little bit more plant life, but it's still pretty barren. This is a species, both these species, the one in the foreground and the yellower one in the background, are in the nightshade family Solanaceae. The one up front is Nolana. This is Nolana rhombifolia. Now, Nolana is a huge genus in Chile. There's got to be probably 80 or 90 species in it. A friend of mine is actually a guy I recently became friends with who used to work for the Field Museum in Chicago, was studying this genus. And in this genus, it turns out we actually found and photographed a as yet unnamed species of Nolana, probably about 140 miles south of here, on this 3,000 foot tall mountain near the ocean. But this guy Michael Dillon, who I know, took a look at it and said, yeah, this is a completely new species. It's never been named before. It's as yet undescribed. So I got some photos of it. I got some video of it too. So he's going to send a scout back down there in the next year or two, hopefully, to check it out. But they're getting as badly ravaged by COVID as we are up here. So, well, maybe not as bad as we are up here. We're pretty we're pretty extraordinary in that regard. But down there, it's bad too. So anyway, so this is Nolana right here in that foreground, Nolana rhombifolia, with those beautiful red funnel-shaped flowers. And then in the background is a Solanum species. This is Solanum pinellii. And it's one of the Solanum species that is very closely related, much more so than any of the purple flowered ones, to our grocery store tomato. And I noticed that smelling it. You could see the hairs and the glands on the stem, and touching this thing, your fingers came off with oils and resin. They smelled like actual tomato plants. Which is, I've seen the genus Solanum in Mexico and in the deserts of Baja, and they're nothing like this. They've got purple flowers. They're not as glandular. They're just totally, most of them are really poisonous, just a completely different plant. Same genus, but it's a big genus, and there's obviously potatoes are in it too, but there's a lot of variation in it. And this subgenus, mostly the tomato-like ones are from Peru and Chile. More intense. So you're going to see everything is hairy. Everything is hairy. Everything has glands on it. The glands also help trap the fog, but I don't think you're getting much fog up at this elevation. Maybe, I don't know. There's that Solanum again, Solanum pinellii. You can see those dissected leaves. And there's more of that habitat. That's Nolana rhombifolia. And there's an up close of the flowers. You can see I dissected a flower here, split it open. You got 5 petals all fused together. Really beautiful color to it. 5 anthers, and then that central style, of course. So now this is a genus we get in California too. This is Trixus. We get Trixus californica. I forget which species of Trixus this was. It's been 8 months. I've forgotten. But you can see those bilabiate corollas. It's sunflower family, Asteraceae. Trixus is a desert species in North America, and it's a desert species or a desert genus in Chile too. So moving on up, we kept going up. Now we're at 8,000 feet, and this is where stuff got really weird. This is when we started to see some of the actual large, tree-like plant life. You can see that cactus right there. This is one of the weirdest plants I've come across in a long time. This is Braningia Candelaris. Yeah, so there's Braningia Candelaris, and you can see you've got some smaller herbaceous stuff. The interesting thing about this too is that it's covered in spikes and spines up to about 10 feet tall, which is about the elevation at which any sort of mammalian herbivore, which is now presumably extinct, but when this thing evolved was obviously still around. It's about as high as it could reach. So it's kind of cool that it's got, this plant for whatever reason has evolved. It somehow, quote, knows to stop wasting carbohydrates and energy producing spines, because these spines, there's a photo of one coming up. I mean, you can see they're almost a foot long. It's a 12-inch long spine. It's very energy intensive to manufacture. And so, however, this plant knew how to stop, whatever evolutionarily occurred, that this plant realized it was it was no need to waste energy producing spines above 10 feet. It's pretty interesting. So you'll see that above 10 feet, they don't have any spines. And you can see these things. I mean, they're brutal. They're like it almost looks like fur. And so above that, it's, and there, of course, there's no way to date cacti. They don't produce annual rings, but some of these have to be easily 200 or 300 years old. I mean, they're so slow growing. And so that's an adult, and then we'll show you some pictures of a much older one. So we didn't see any herbivores. They've all mostly retreated to higher elevations. It's too dry for them now, but presumably at one point, maybe in the Pleistocene, there were guanacos or some sort of other camelid, camel-related herbivore gnawing on these things. And apparently the Braningia Candelaris genome codes for ceasing spine production above 10 feet, which is pretty cool, pretty remarkable. There's a spine. You can see that. That's about 12 inches. And there's, you can't tell, but I took this photo standing over a crevice looking at one that was, growing about 12 feet below me. So this is the top. This is a eye level view of the top of probably a 13-foot tall plant right here. And so this is what they look like after they've ceased producing spines. So it's kind of just these little areoles with a bunch of glaucids on them, glaucids and trichomes and stuff. So there's a young one. There's a couple of adults. There's the fruit, which was kind of cool. I brought some seed back, mailed it to a friend at Denver Botanic Gardens and some other places that will hopefully grow them. But again, this thing, it's such a weird and distinct climate it grows in. I doubt they'd have much luck growing it here. It's so dry. So plants, of course, that are normally from exceptionally dry climates, you bring them to anything that gets more precipitation than that, and you don't control for that dryness, they tend to rot pretty easily. So we'll see. I don't know. So now we're getting to some of the old guys, the super, they've got that kind of mushroom habit to them, kind of like an Araucaria. And there you go. I mean, that thing's got to be 600 years old at least. Totally one of the weirdest plants I've ever seen. I've seen a lot of weird plants. So anyway, so moving up, this is probably 9,000 feet now. This is Cistanth, which is yeah, bitterroot family Montiaceae, and this this genus is everywhere, you know. And I gave up trying to key out which species they were. Well, I didn't have a key to begin with, but I don't even know if there is one. But they're just so ubiquitous, and they're beautiful. I mean, you can see they're in Caryophyllalia is the order, same order as spinach and beets. But of course, Montiaceae, the family, same family as Lewisia, the bitterroot. But they've got those betalain pigments, which, you know, a lot of plant families and Caryophyllalias have, which has a distinct color from, you know, it's a distinct red color, a distinct red pigment from a lot of the other plant families that use anthocyanins and carotenoids to produce their red pigment. So betalains were named after the beet, after Beta vulgaris. And once you know what the pigment looks like, you can sense it, and you can see it in a lot of families in that order, Caryophyllales, like this one right here, this genus Cistanth. So Balbizia microphylla. This was a weird one. When I first saw it, I thought it was a member of the rose family, Rosaceae. It's got 5 petals. It's got, I mean, it just looks like a rose, but it's in a completely unrelated family, the Francoaceae. And this is a very common plant in the Atacama Desert. There's the sepals, nice money shot of the sepals. So now going up to 10,000 feet, this is one of my favorites. This is a Chuckyuraga spinosa. It's in the sunflower family, but it's in a subfamily called the Barnardizoideae, which is, you know, again, it's one of those earlier branching lineages. And it's distinct too. I mean, when people who study composites, the sunflower family, studied the Barnardia subfamily, they realized that there's a huge, like 21,000 base pair inversion that's present in the rest of the family. All 27,000 species of sunflower family members that this subfamily doesn't have. The Barnardia subfamily also tends to have these thorns, like you can see right there, lots of spines and thorns and multi-seriate phyllaries right here, those little roofing shingle bracts, all imbricate, you know, just like roofing shingles. This is obviously hummingbird pollinated, like a lot of plants in South America are. Anytime you see a red, long tubular flower, tubular red or purple flower, it's likely hummingbird pollinated. So this thing was everywhere. It formed a small shrub, maybe to like 5 feet at the most. Got some seed of this, gave it to my friend Martin, and he's growing it right now, but they're slow. And this is at like 10,000 feet. When we got up to this elevation, it was pretty cool. It reminded me a lot of, areas in northern Nevada, just that kind of coloration, the volcanic soil, all the plants were kind of lime green or beige colored and just super dry. But again, we're closer to the Andes where there's snow and where they get more precipitation, those high elevations, that there were creeks running through here, and so there was more vegetation. There's a close up of those trichomes on that leaf. I mean, look at that. That's totally, remember the atmosphere is thinner, solar insolation is more intense, and also there's probably some frost protection too. It does, I think at this latitude was only 19 degrees, which is not, 19 degrees north is like the deserts of Mexico, almost subtropical, but you're still so high up that it doesn't matter. It's, you do get frost. So that's Chuckyuraga spinosa. This is a member of the Solanaceae. This is a species of Dunalia. Again, hummingbird pollinated. And it's cool to see the same traits converging across different plant families. I mean, this is Solanaceae. The one I just showed you was Asteraceae. But look, more of that pubescence, the spines, being in a dry environment, there's not much growing around. So what is growing around is going to get munched on quick. So it's going to develop, plants are going to develop, spines and defense against herbivory. And of course, in protection against drying out and that UV light, you'll form a lot of hairs. So this almost looks like an Iachroma, which is in the same family. You see Iachromas a lot in the Bay Area in horticulture. But great plant. I got some seed of this too. I have yet to try and germinate it. And there we go. Old man of the Andes, Oreo Sirius Leukotrichus. Who knows how old this was, but you could see it. We got a lot more vegetation here. It's and weird cacti growing nearby too. There's close-ups of that Oreo Sirius. So you could see that some of the radial spines of this genus, because cacti have central spines and radial spines, some of the radial spines have been modified into hairs. I mean, a lot of them have been. Again, protection against frost, protection against UV radiation. And this is a hummingbird pollinated plant. The flowers are red and tubular, and then it gets these little almost tomato-looking yellow cactus fruits on it. And this thing was ubiquitous at the higher elevations in the Andes. This species was. So right here, you know, you can see it's super toasty and dry. And right there is another extremely rare cactus called Neowerdermannia. There's a close-up of it. Neowerdermannia chilensis. You know, and that's, I mean, it's cool to see this too. I mean, it's a lot of cacti, of course, don't just use spines to defend themselves from being eaten. They also do this almost kind of biomimicry, this phytocamouflage, and that's what this guy's doing. I mean, he blended in so well. So, all right, so moving on up. Now we're at 13,000 feet, and this is anyone who knows anything about Andean botany, one of their favorites. This is Azarella Compacta, and it's a member of the carrot family, but it's a carrot at high elevation. So it's what another once you get to a certain elevation, and this is probably this has got to be 13,500 feet right now. You start getting more traits that are convergent against unrelated taxa. These little mats down here are a member of the Caryophyllaceae. They're in the genus Pycnophilum. And everything, you know, not everything, but 90% of the plants at this elevation become carpets. They just become these mats, these cespitose little mats, because if you get any height to you, you're going to get blown down by the wind. And also the ambient temperature is, you know, a few degrees warmer closer to the ground, whereas, you know, it gets really cold really fast the farther away you are from the ground, especially at night. So it's another trait convergent amongst whatever plants are able to eke out a living up there. This right here is a member of the this thing poking out that seemed to have got some height to it. It's a genus called Peristrefia, which is kind of analogous to, like, it's in the sunflower family Asteraceae, but it's analogous to like some of the Chrysothamnus or Ericomerias that we get. And it's got scale-like foliage. It looks like a juniper, super weird. I mean, this is one of the weirdest habitats I've ever seen for plants. It was totally incredible to be up here just to see, you know, what life does when faced with this kind of elevation. I mean, it kind of, you know, we spent like the entire time we're up here, we're chewing coca leaves, we're, you know, experiencing hypoxia, lightheadedness. You know, I felt like I drank too much cough syrup. It was just, I mean, you feel the elevation. I mean, this is, you know, California's highest peak is what, 14,000? And, you know, in the photos coming up, we got up to like 15,300 feet. So this is Azarella Compacta. And these mounds go down about 10 or 12 inches. It's a really thick plant. You can see it's just forming these little alien looking blobs off in the distance. There's that Pycnophilum again. Looks like someone's dog threw up on the ground right there. And there's a close up. That's another cool thing too, is so it's the carrot family and you can smell it when you get up close. A lot of members of the Apiaceae, you know, produce secondary metabolites called furanocoumarins, which help protect against being gnawed on. And that's what gives, you know, parsley and cilantro and carrots their smell. And this resin, I put some on my hands, and it smelled like carrots. It smelled like parsley, the distinct smell of that family. Here you could see all the flowers completely sessile, no pedicel whatsoever. And basically what it is, it's just a bunch of tiny rosettes of leaves all compacted together. Right there. Totally incredible plant. Can live for, 2 or 3,000 years and just totally adapted. It's been through the filter of however many millions of years of evolving to grow in that habitat. There you can see the stamens. The flowers must have been, I don't know, 10 millimeters across, if that. There's pollinator flowers. Those are ovaries, the typical Apiaceae schizocarp. Got some seed back, brought some seed too. There's the seed, mailed it to Denver Botanic Garden, which is probably one of the only places that might have luck growing that. They got that kind of high and dry climate. So moving on up to 15,000 feet now, this is where stuff gets even weirder, if you can believe it. There's an active volcano. There's all the lava flows at the base of it. You can see those. And this is one of the coolest plants that we came across. This guy right here. It's a member of the genus Polylepis, and it's in the rose family. It's the highest growing shrub, woody shrub on planet Earth. The only woody shrub that you really get above 15,000 feet in elevation. And there was some really cool stuff here. Again, landscape's entirely volcanic. Look at that pink andesite. There's Polylepis, Tarapacana. There's the leaves. They're not dentate like most members of the rose family have leaves are, though, which is I thought was kind of odd. They're actually growing a species of Polylepis. It might even be this one at the University of California, Berkeley Botanic Gardens. They just put them in. I don't know how they're getting them to grow, but you could see that papery bark just acting like insulation against that cold. Probably, 2 or 3 inches deep, this bark. And growing at the base of the Polylepis was this kind of thing. Looks like some sort of weird coral, like this kind of papillose, leaves, blends in with the rock. Super weird. I couldn't figure out what the hell it was. I was racking my brain trying to figure it out, trying to find one in flower. And I finally found one in flower, and it was gynophore. All the stamens and the gynoecium fused to the same central stalk, just like hibiscus gets. And there it is in habitat. Tiny little guy right there. There's some camelids for you, some guanacos. Just hanging out in this marshy area. There were flamingos here too. You can see one right there. This is back down at like 13,500 feet, maybe 14,000 feet, a little bit lower. More flamingos. Flamingos and guanacos just enjoying life together. Continuing south. So this is back down at about 9,000 feet. This is one of the coolest plants I've seen. And it was the first Chilean observation of this plant on iNaturalist, because it's mostly a Peruvian plant. This is Bulmaria Envelocrosa. And these stalks were probably 7 feet tall at the most. Just super weird looking pendant flowers. It's a monocot, so flower parts in multiples of 3. I've never seen anything like this. It doesn't look like, I've seen Bulmaria in Mexico before. They've got some Bulmaria at UCB gardens as well. Looks nothing like this. Just totally such a cool plant. So this is up at 15,000 feet, and this is on the Altiplano. This is like your quintessential Altiplano columnar cactus. This is a Trichocereus Deserticola, and there's got to be, you could see there's hundreds of them right there, maybe 1,000. And this thing, again, it's these cacti, quote, know to basically turn off the gene that codes for producing these thick armaments of spines, which again have to be very energy demanding to produce. How does it know to turn them off above 9 feet that you just don't need them anymore? Probably it was, you know, something, the ones that kept producing spines above 9 feet ended up dying out, just wasting their energy. And so, you know, chance mutation arose, and those, that chance mutation just succeeded. But it's still a pretty weird, it's a pretty weird thing that I noticed a lot of cacti do there. So getting closer. And again, this is, I mean, this is probably the highest I've ever been in my life on land, you know, not in an airplane. This is like 15,500 feet. And that was, I mean, I had an altimeter on my phone. I was just, everywhere we went, I was constantly measuring what elevation are we at? What elevation are we at? This is probably 20 minutes from the Bolivian border. There's a young one, just thick spines. I mean, you don't want to touch it. They're bat pollinated. Okay, you want me to move over there? Yeah, can you guys hear me okay?
You keep going in and out a little bit.
Really? Let me see if I can get closer. Maybe that'll, all right. All right, let me see. All right, maybe this is better. Yeah, yeah, speak up if you can't hear me. Have you guys been able to hear me or no? Yeah.
Cut out a bunch.
All right.
Yeah, you just cut out at sort of somewhat regular intervals, but we've gotten most of what you've been saying.
I'm sorry, say it again.
Oh, just that you've cut out at somewhat regular intervals, but you know, luckily it's been in short bursts, so we can hear most of what you're saying.
Oh, okay.
And we can see the pictures.
Bummer. All right. Yeah, sure. All right, let's see. Hopefully that's better. All right. Oh, okay. So let's see. I think that might be the end of it. Yeah, that's the end of that presentation. So let's go to, what do I got? I got a couple more for you. And let's see. Okay, so this is a little bit south and closer to the coast. So we drove through the Atacama Desert, completely barren, nothing was, I mean, miles without any plants. And we're probably at an elevation about 6,000 feet, descending towards the coast. And around 3,500 feet, we started seeing some started to actually see plant life, and there you could see this is probably 4,000 or 5,000 feet. You could start to see the fog, just an enormous fog bank with the Pacific Ocean in the distance, but still totally barren volcanic soils. Right there, you could see some sestamp. No idea on species, but succulent, betaline pigments, Montea, obviously. This guy was really cool. This is a member of the blazing star family, the Mentzelia family, Loasaceae. This is Huidobria, was the genus. And it was literally the only thing we saw in this area. There's the flowers, Huidobria fruticosa. Of course, if you know anyone who's familiar with Loasaceae knows the leaves are kind of like Velcro. Like they'll stick to your shirt. You can take the leaves off and actually get them to stick to your shirt. And that's what's going on here. Well, I'll get a close up of the leaf. The flowers were totally incredible. 5 distinct white petals with sepals alternating in between. Tons of stamens, just like Mentzelia. And then there's an up close of those leaves, just covered in, the hairs have barbs on them. So they don't hurt, but they're literally like Velcro. And so that's just, I mean, it's crazy. This thing holds on to every little bit of moisture that it gets. It doesn't transpire much. And this was, I mean, there's ultraviolet radiation is not as bad at this elevation because the atmosphere is not as thin, but it's still just super dry and super barren and super exposed. Couple 100 yards down the road, we saw another mutisioid member of the Asteraceae, the sunflower family, the Oxyphilum, Ulyssinum, bilabiate corollas, like many of the mutisioids. But the mutisioid refers to the subfamily Mutisioideae, which is another one of those early branching lineages of the sunflower family. And the thing that really struck me about every member of this family that we don't really get that many in North America. We get Trixus, we get Acortia, we get maybe 1 or 2 others, but down there, so many of the composites, so many of the sunflower family members are mutisioids, which makes sense because South America is where the sunflower family originated. But down there, I'd call them dinosaur sunflowers because they're just so weird and the foliage is always super leathery and spiny and hard and sclerophilous. There's another one, Gypothamnium pinifolium, just really, really cool variations on a sunflower, especially if you're used to North American members of that family, which I am. So moving along, we're now about 3 miles inland from the ocean, headed towards the ocean, but we kept seeing cool stuff to pull over and document it. In the foreground, you have a species of Areocytes, which is a really cool genus of South American cacti with pink flowers and often black epidermal tissue, like darker epidermal tissue. Some of them look almost black. And then the background, you have Oxalis gigantea, which is a succulent oxalis, which was super weird to see. I mean, oxalis, you know, we're used to them up here as the wood sorrels, or a lot of them as obnoxious weeds and you know, container plants. But I mean, here's a variation on one that's succulent and, you know, basically a shrub. And there's those leaves too. And there's that Areocytes, Oxalis gigantea flowers. And then, of course, Copiapoa, one of the Chilean endemic cactus genera, which basically, I think all the Copiapoas are low elevation. All of them occur in the fog belt, and there's probably 2 or 3 dozen species, I think. This was Copiapoa calderiana, and the entire hillside was just covered in them, you know. But again, you can't date cacti, so who knows how old they are? But they gotta be old because this place barely gets any moisture, just fog. And so this was like 3 p.m. in the afternoon, and by 5 or 6 p.m. that night, I mean, we experienced the fog. It just rolled in, just like it does here. You know, higher elevations, 1,000 to 2,000 feet up, you get these just massive clouds of water vapor moving in off those cold ocean currents. This was another species of Nolana, variations on a theme. There's like, remember I said there's 80 or 90 species of Nolana, that genus of nightshade. Here's another one, but kind of Sespetos forms a map, but totally distinct flowers. Kind of succulent. It's weird. Yeah, it's weird to see basically like a succulent nightshade. Another mutisioid aster. This thing, you know, it just kind of looks like a typical dandelion weed, but then you get up close to it and it's got these just incredible color to it. You know, all the Catanthera, which is this genus, have those, there's the whole flower heads, you know, subtended by these really cool keeled bracts. I saw another one in the Andes at like 10,000 feet. It was only like an inch or two tall. It was an annual, but it had that same, these spatulate bracts around it. So moving on, Tropaeolum. We know Tropaeolum up here is the common garden nasturtium, which is kind of a misnomer because it's not in the genus Nasturtium. Nasturtium is in Brassicaceae. This is in Tropaeoliaceae, which is in Brassicales, the order, but we don't get any native species in the northern hemisphere at all, I think. I think it's entirely South American. But, you know, another genus that's got 12 or God knows how many species in it. Some of them get really, really cool. This is Tropaeolum tricolor. It's kind of like a climbing vine. And they all have that sepal that forms a little nectar spur right there. More of that areocytes. Remember, all the precipitation here is solely from fog. Except, you know, once every couple years it rains. Another Talanzia species, Talanzia Geisii, which I was stoked to see. Obviously, it's hummingbird pollinated. You got those tubular red flowers and just covered in trichomes. Just a nice silver color to it. And this is that same location, but I don't know, maybe 500 feet up. It looks like the land had been cleared for agriculture a little bit. Kind of hard to tell. The columnar cactus is Eulychnia. It's a species in the genus Eulychnia. And this one down here is Trichocereus Deserticola. And this is probably 5 or 6 p.m. at night, and the fog just rolled in hard. A species of Senecio. There's a ton of Senecios in Chile. But look at the size of this cacti. I mean, that cactus is just covered in lichen. There's like 12 different species of lichen just draping this thing. Not harming the plant at all, just, you know, a fungus and an algae doing their thing, you know? But only where there's enough fog for them to be able to exist. You go 5 miles inland, there's nothing. There's not a single plant. Maybe a ciscanth every now and then. That's it. I mean, it really, I've never had such a hard time figuring out how life survives. Remember the Amaryllidaceae Rhodophiala pratense? This was one of 2 species of Rhodophiala we saw, and these things were just, yeah, popping up right there in those barren fog-draped slopes. Totally stunning flower, though. Of course, with that nice corm in the ground, volcanic soil. Trichocereus Deserticola in bloom with that Senecio coming up in the middle of it. So this is the next morning, Copiapoa gigantea. And I forget what this was. I should have, it's probably an Alana of some kind, but. And that's the ocean, probably 100 yards off. And the weird thing about many of the copes is that they form their, you know, they have, most of them have numerous spines per areole at first, but as they age, they only get one. Like a lot of them only get one spine per areole. So they kind of look like the Hellraiser from that Wes Craven movie. Just super weird plants. Species in the Catalpa family, Bignoniaceae, Argylia radiata. And then this is later that day, after we climbed up this sketchy slope. I kind of skipped over that part. Totally sketchy, treacherous, just really steep and unstable talus. This is a species of Puya, which, you know, you see in gardens occasionally here. It's a xeric bromeliad. But, you know, no one grows. over this sketchy cliff. So again, we got Eulychnia right here. We basically hiked up to here. No trail, nothing, just kind of hiking along. A friend of mine found a really cool, almost looked like a Clovis Point right around here. That was God knows how old. He left it there, of course. He didn't take it, but it's so much is brushed up against it, just starts leaking this resin, you know, that toxic euphorbia resin. It's pretty funny. It's just totally, you know, it looks like milk just pouring out of the stems of these things. There's an up close, some more of the lichens on some of the Eulychnias. This was a cool plant. This is distantly related to penstemons. It's and it looks like a penstemon too. The flowers do. It's Plantagenaceae. This is Montea Chilensis, and we found out later it's an extremely rare plant. It's pretty threatened in most of its range. Opposite leaves, kind of alternating orientation each node. And there's the flower. You can really see the penstemon, the penstemon in it right there. Okay, another member of that velcro leaf family, Loasaceae. This is a species of Loasa, and these things had these, and there was another genus called Chiophora, and they had these brutal spines on them. I mean, they just urticating hairs. You touch them and they sting you, and it hurts. It lasts for like a day. Two different species right there. And I think that's it. Yeah, that's it for now. So we'll go to New Caledonia really quick. Give me a break, 1 second.
Okay. Does anybody have anything to say, to add? Art and I went to Chile this in November, very similar to the path. I think we saw that same Loasaceae plant where he said that there was only one plant. I think we saw that exact same plant on the road with nothing else on there. Bart, you have anything to say?
Yeah, well, that was the Eudobria. And we actually saw 3 of them, but there was only one in good condition. One was dead and one was almost dead. But like Ellen said, it was the only thing that we saw in that spot. There wasn't anything else. Some of those cystanthes, we actually do have the species on them, and I do have them written down. So if anybody wants them, I can look them up. The one that had sort of the thicker leaves, I'm pretty sure that one was Pseudoides after sedum. Anyway, very interesting images. It's been fun. I'm going to mute myself.
I wanted to add, Kristen had this man, Chad, right? Chad, what was his name?
Chad Hughesby. He's going to be our speaker in October again.
Yeah, that was an incredible presentation too. I still remember everything he was sharing about the Equisetum. And I do remember he was talking about the one in the Atacama and how it was really filtering out the bromine, high salinity, and transpiring actually potable water. Right? You remember that?
Your memory's better than mine, but then Equisetums, I brought him in because Martin told me that we needed a program in Equisetums, and so I do what I was told by Martin.
Mm-hmm.
If it isn't a flower, it's not as exciting to me.
Yeah, he said that some of the ones that he found in the Atacama had stalks that were as thick as his arm.
Right.
Yeah. Yeah, there was Chad Hugsby was this speaker a few years ago that we had who was talking about Equisetums, and one of the species in the Atacama apparently, like, well, we learned a lot about it at the time. Yeah, it's interesting.
I remember being impressed with what good survivors they are, you know,
Yeah.
how impossible to do. And I kept waiting for the secret, you know, what's their mortal weakness, but I'd never heard one. So,
Well, they're like 350 million year old fossils of the Equisetum. They're just ancient.
yeah, makes you wonder how old the plants themselves are. I'm not sure how you would determine whether, you know, you are looking at new generations or 1,000-year-old plants, you know, since they seem to be way underground and send something up through whatever you plant.
What was memorable is that their spores actually move on their own because there are these chains of proteins that flex with the fluctuations in humidity. Do you remember that?
No.
Yeah, dancing with the spores. You can watch them dance away.
Really?
You
Yeah.
like strange stuff, Patty.
Oh, well, I have a pretty good
I
memory.
remember that too. It was that he even showed some videos.
Yeah, he showed us a time lapse of that. Wow.
Yeah,
What
it was
did he present then? Did he
and
present?
that
just
it was
Equisetum?
all, I believe, Equisetum Gigantium, which is very, very widespread and not always gigantic. And that the ones that he was saying he found in Chile, I believe, were smaller than the ones that were in more tropical areas.
Okay. Wait, all right, so should I start again?
Sure.
Yeah, that'd be great. It's 8 o'clock, so maybe on like another half hour.
Okay, yeah, this probably won't even last that long. I mean, I was kind of a pain in the ass putting these things together. I had to individually select every photo, so it took me a while.
Well, we're enjoying it for sure.
But okay, so this was New Caledonia. I've been wanting to go there for a while. A lady in the UK liked what I was doing and basically sponsored me on a trip there to just go and document the flora. And I went at the same time that a friend of mine was going there to study. He was studying Araucaria humboldtensis, which the trees are afflicted with some sort of fungus. I believe it turned out to be a verticillium of some kind. But the humboldtensis, there's about 13 species of Araucaria there. You know, super old lineage, Jurassic age lineage of tree, and they look like it too. But most of them grow high up in the higher elevation areas where they get more rainfall. The lowlands of New Caledonia are super hot, super humid. And we were, you know, I was there during the rainy season. It was February. It was right before COVID broke out. So, but I got Amberella. I didn't put Parasitaxis up on this page. But anyway, okay, so this is the southern part of the island on those ultramafic soils. The serpentine there looks just like the serpentine, or it has areas that look just like the serpentine in California, but being that it's a more tropical environment, there are areas where it weathers a lot differently. So it's there's areas where you could see typical blue serpentine outcrops, like just like you'd get in, like, you know, Sonoma County or something. But there's other areas where it doesn't look anything like what we get in California. It's so oxidized, it's so weathered, it forms this kind of laterite clay almost, just super iron-rich clay. And this plant was ubiquitous on all of the serpentine at the lower elevations. This is Gymnostoma diplankianum, and it's in the Cassarinaceae, so it's got that actinomycete bacteria, that nitrogen-fixing bacteria on its roots, like many of the Cassarinaceae. You know, I had only been familiar with Cassarinaceae from Australia before, like Alocassarina and Cassarina. This one was new to me. Basically, you know, photosynthetic stems, nearly absent leaves, and it, you know, tends to look a lot like a conifer even when it's in fruit, but it's actually somewhat related to oaks. So there's that branching structure, and there's the mature fruits. They kind of look like cones. And I got a couple seeds of these and I'm growing them right now. They are slow. It's like they germinated 6 months ago. They're still like an inch or two tall. But this thing was everywhere. There's 2 species of Gymnostoma on the island. This one and then one other one. But yeah, it looks like a conifer. So what is going on there? And this was, I believe, Cyathopsis. I forget. It's a member of the Ericaceae. It's formerly Epacridaceae, the southern hemisphere heaths. I believe it was Cyathopsis cooperi. I'd have to, you know what? Let me look for a minute. Because there's quite a few. If anyone who's familiar with some of the southern hemisphere Ericaceae, they look totally different. They almost look like monocots. Some of them do. I mean, you can note the parallel venation in the leaves right there. Just totally bizarre plants. And this thing was common too. It's a serpentine tolerant Ericaceae, tropical Ericaceae. And these were, that's not blooms, that's new growth. There's another genus begins with an L. God, I forget the name of it. I've seen it in Australia before too. But yeah, this is Cyathopsis albicans. And then there was, I think Leukopogon. Leukopogon's the genus I was thinking of in Australia. Same thing. They get their new flushes of foliage have this kind of conifer look to them. These imbricate scale-like leaves that as the plant matures, of course, turns into this kind of foliage. But when it's first popping out, it looks wild. These are the flower heads. Not in bloom yet. Pre-anthesis, when they open up, they do look like an ericaceous flower, typical 5 fused lobes, almost kind of like a manzanita. Another ericaceous ultramorphic plant. This is Stiphelia. I believe they actually moved Stiphelia to Leukopogon, but I don't know. It looks so distinct. You can see that red flush of anthocyanin pigments in the new foliage that's emerging. And this is another one, super weird. And it actually provided habitat for mosquitoes to breed in, you know, having those kind of those little tank-like leaf blades that would hold water. This is a Dracophyllum. There's a bunch of different species of Dracophyllum. There's like 4 or 5 on the island, but you can see the old flowers. Yeah, they look ericaceous enough. Nice ultramorphic outcrop. You can see how it weathers too. Super weird. So this, you know, the idea being that New Caledonia was once part of Australia 80 million years ago, and then because of continental shift moved away. It was abducted, so like partially subducted, and then the geology of it's super weird, you know. So it's basically a slab of oceanic crust that got abducted on top of part of the continent. Why does it have so many ancient lineages of plants? I haven't shown you any yet, but it does. It's got ambarella. It's got all these weird araucarias. You know, it's gone back and forth. The argument was that it was basically like a time capsule, like a botanical lost world. Then this other guy came out, this geologist, and said, no, that's impossible. This whole continent was buried in the Eocene roughly 50 million years ago. So it must have been entirely recolonized by all these ancient lineages of plants, which seems pretty preposterous when you think about it. Why wasn't New Zealand colonized by ambarella and all these ancient lineages of plants? Why wasn't Australia? I mean, they both have old lineages, but nothing like New Caledonia has. So now the general consensus is that yes, it was buried by the ocean. It was sunken for a while, but there must have been refugia poking up above sea level for many of these taxa. Some of the more tropical stuff you'd see in Papua New Guinea, or on New Guinea. So anyway, this is Parsonsia. It's a Postanaceae, oleander family. Parsonsia flexuosa. Nice close-up of the flowers there. This was like a climbing vine. Again, an ultramorphic. All these plants are adapted to that harsh soil chemistry that, you know, super high levels of magnesium and iron and nickel, especially lots of nickel mines on New Caledonia. This is a ultramafic tolerant Nepenthes. This is Nepenthes viardii. And these are all basically just infructescences, masses of fruit. This is the south end of the island. You can see that red. I think this is mostly due to mining. So there's mining has been so damaging to the ecology there. But the color on that Nepenthes was crazy. Only species of Nepenthes on New Caledonia, but it was pretty common at the lowlands, the low elevations. And you could see the way this stuff weathers, just totally weird. Just basically just, you know, reacting with water. I mean, obviously in a tropical environment, you get a lot more moisture, a lot more heat, a lot more oxidation, and this stuff just kind of melts. And this is what I'm talking about, where it starts to form these kind of weird lateritic soils, just kind of like iron-rich clays. This is Araucaria muelleri. Old logging road or mining road. There's a more Araucaria muelleri. God knows how old that is. I mean, they didn't really get too much taller than that. Maybe 3 times that height at the most, but they stayed pretty relatively low. This is back down at the lowland. This huge serpentine outcrop on the right here. Super crystal clear water. And completely just just serpentine outcrop right here with a huge mat of that Nepenthes, that pitcher plant growing down there. It's so weird. It's so weird to see a species of Nepenthes on ultramorphic soil, but yeah, this is a super rare plant. I believe it's only known from this area. This is the shoot. Growing here was Retrophyllum minus, just a whole close up of that Decridium. There you go. There's a nice illustration of the local geology.
Joey,
Yeah.
can you go back to that plant because we missed the name of it completely?
The Decridium. So it's a Podocarpaceae.
Okay.
This is Decridium gilmanii. It's Guil. I'll have to look up the spelling.
Don't worry, we just didn't hear you at all. So
Did it cut out? Did it cut out or something? Or?
Totally. Yeah, we didn't hear anything about that plant at all.
Oh, weird. Yeah, I was just saying it's a just very rare, localized, endemic species of Podocarpaceae that you know, they don't get too tall, maybe 10 feet, but endemic to this one area. That's the only place in the world that it grows. And there's the that kind of laterite. This was really weird. Felt like plastic, but like iron-rich kind of lateritic soil. We get lateritic soil in California, you know, like you go to like Ione. It's basically just very iron-rich, you know, forms in a warm, tropical or subtropical, humid environment, but just basically, you know, oxidize the ultramafic soil. This was a species of Xanthostemon myrtaceae, the myrtle family. There you go. There's a nice close-up of it. And I actually got seed of this and gave it to my friend Martin, and I think he got some to grow. Yeah, that was a pretty common genus there. There were quite a few species. But, I mean, you can see this whole area is just barren. I mean, it's like pavement, basically. So this is above the waterfall. This is right, like the waterfalls to the left. And there's Araucaria rulei. just two or three trees popping up above a little low-growing forest there. So of course, ultramafic soil is super nutrient poor, not a lot of calcium, not a lot of nitrogen. The forest isn't going to get very big there. You know, just like here, all the plants are relatively pygmied and cut short.
Is it volcanic at all, or what?
No, it's ultramafic. So it's like our serpentine, just associated with subduction zones, basically oceanic crust that was metamorphosed. It's like metamorphosed peridotite. It's you normally don't get this rock on the surface of the earth.
Oh,
When
interesting.
you do, it's only because of tectonic activity, because of uplift.
Okay.
Basically. So this is Neocalotropsis pancheri. I believe they put it in Calitris. So it's redwood family, the cypress family, but it's been separated from the redwood branch of that family for a very, very long time, probably 70, 80 million years. Another Jurassic age plant lineage right there. And here it is, just forming a forest of these just super stunted and pygmied trees growing basically out of pure rock. Totally weird plant. And this was one I've been wanting to see for a while. I used to volunteer at Stribing Arboretum, and I got someone to send me seed of this probably 12 years ago and got it to grow, but it just rotted away. Just must not have been accustomed to our host of fungal pathogens in the Northern Hemisphere. You could see it's just everywhere here. And there's that soil. I mean, look, it's staining it's just like this red iron-rich dust. Staining the roots right there pretty good. So Myrtaceae and Podocarpaceae and Cupressaceae to a lesser extent are three plant families you get a lot of in New Caledonia. And everything on that island is expensive as hell, of course. So, you know, we were like eating canned beans and bread and cheese. And this you can't really tell, but down here, that white popcorn looking stuff under the Neocalotropsis was a species of lichen. And there was a lot of it at higher elevations. It's kind of coralloid lichen. I got the genus written down on my iNaturalist, but it's been 9 months, so I've forgotten. This is a Decridium ericarioides, another podocarp, but I mean, I think it's got to do with the soil chemistry. I think it's an adaptation to that really harsh soil chemistry. And, you know, I've seen people grow Neocalotropsis, that other plant I was just showing you, for instance, on regular soil, and it takes on a completely different form. It looks just like a regular conifer, but you grow them in this super nutrient poor ultramafic soil, meaning ultramafic, magnesium, and Fe for iron, you know, nutrient poor. Basically, the soil is just extremely harsh, and it causes this really weird, I don't know if you'd call it a deformation, or it seems like more of an adaptation, but you know, you're not going to be thick with foliage if the soil's that poor. And you see it, you know, in some of our California endemic ultramafic plants too, like Sargent cypress. You grow Sargent cypress on regular soil, it behaves like a regular tree, but you grow it on serpentine soil, and they grow stunted and super weird and pygmied like this too. So when I was at the herbarium in New Caledonia, I met a guy who was actually working on a paper on this growth habit, which again is convergent against amongst so many of the plant families over there. And I think this is just about it. I got way more to add, but this is Ambarella trichopoda. Doesn't grow in ultramafic soil. Grows, you know, in the shady understory of basically rainforests, of tropical humid forests. You know, flying foxes high up above, darting in and out of the trees. I was here during a thick downpour, and but it's, you know, it's one of the earliest branching lineages of flowering plants. It's, you know, it doesn't have vessel elements like and you know it's not a big tree. It's tops out at like 10, 15 feet, and you would just easily overlook it if you didn't know the context of it. I mean, this is really not necessarily where it all began, but it's basically left over. It's a remnant from that time period when angiosperms were first getting going, and it totally, when you get up close and look at it, it totally looks like it too. It's just a really weird. I mean, look at the way that these petioles branch off, and they had this kind of glabrous feel to it. The flowers are, of course, just axillary. And I brought seed of this back and I just got one of them to germinate. And that's what, you know, friends, I had a botanist friend who lives in New Caledonia. Actually, he told me, yeah, you just basically, you sow the seed and forget about it. And so at some point in the next year, they'll pop up. And mine popped up, but it still had the seed. It's not shaking its seed coat yet. And I'm too hesitant to touch it because my heart's going to break if I destroy the seedling and trying to take the seed coat off. So just give it time. But the thing I wasn't expecting was this algae that was all over the leaves. I thought it was some sort of fungus, but no, it's just a species of algae that grows on the leaves and doesn't really seem to harm the plant too much, but just kind of hangs out. But it was on everything. So I think
Did you find any agathis, cowrie for it?
Yeah, I do. I've got some on my hard drive, actually, if you want to bear with me while I search for it. Yeah, we saw Agathis ovata. We saw Agathis morii. Ovata was a weird one. I mean, that's a serpentine-tolerant plant, very blue. And find you some Agathis ovata.
The reason I was wondering is the kauri in New Zealand is a massive tree, like our redwoods, and I was wondering, everything you've showed us so far is stunted looking.
And what did you say?
I said the kauri in New Zealand is a massive tree, like the redwood, and everything we've seen so far that you've showed us is sort of a stunted growth.
Oh yeah, no, I think morii. Because the whole island's not ultramafic, but Agathis morii turned into like a large tree. It was a large growing tree. We saw it with Ericaria labenfelsii in some of the slopes, and that got upwards of probably, I don't know, 90 feet tall. But ovata was a very small tree. So all right, I'll share desktop again, and then let's go into the hard drive.
And if you do have any images of Parasitaxis, that would be interesting to see.
Yeah, I got a bunch.
Great.
Yeah, I mean, I must have taken 15 gigabytes of photos when I was over there. So, all right, let's see. Oh, there was that Drosera neocaledonica. Super weird one. Just growing out of basically pure rock. All right.
Did they have any carnivorous plants beside the Drosera? I guess
Drosera and Nepenthes, that was it. Oh, that was an orchid. Podia albicans. God, what a cool plant. With these bulbous, inflorescences. Yeah, this is Cunoniaceae. This is another family. Was it Cunoniaceae? I forget. I think it was Cunoniaceae. I should have refreshed myself on some of the taxonomy here, but. And that was another thing you see with with a lot of the leaves there. Another convergent trait. These really, velvet-like abaxial surfaces, but super wide leaves. Anyway, that's a species of Codia. There's Neocalotropsis cones, Flagellaria, and let's get some ovata. There you go. So there's Agathis ovata. Beautiful leaves on it too. There's more of that Codia. You could see, I mean, that's like the typical habitat, just, open, exposed, ultramorphic, that bright red oxidized soil, and maybe 40 feet tall at the most, but just super, they spread out. They look like some of those African. Now, let's find some Parasitaxis. More Sphaelia. All right. Oh, some of the meradioid ferns were super weird too. Some of these things. This used to be, I think this used to be in the genus Meradia. Now it's in Tysana with a P, P-T-I-S-A-N-A. But they almost look like cycads, and then they'd have these basically almost like a 20-foot long petiole, a 20-foot long rachis, like a leaf stalk. They were just everywhere, but that was in the lowlands. Of course, Eusporangia ferns. A weird story too. So let's find some cool Hoyas. You know what? I think the Parasitaxis. There was this one spot we went to that it was on top of this mountain, this Coreopsis gigantea. It was on top of this mountain, and there was Ericaria Muelleri up there, and the lowlands. There was that enormous Cyathea, like the largest tree fern in the world. It gets up to like, Christ, I don't know, 100 feet tall. But when you get to the top of this mountain, it was just total, just kind of this area right here, just low growing. That Lycopodiella was everywhere. Ericaria Muelleri as well. This is what the top of this mountain. This is like 4,000 feet elevation. Just super low growing, ultramorphic. Ericaria Muelleri, and then there was this little like divot, because sinkholes would open up, I think, just from the soil weathering. And there was this little divot in the top of the mountain, and it was overgrown with the host plant for Parasitaxis and Ericaria, the Falcatifolium taxoides, that other podocarp. And so it created like this little, I don't know what you would call it, like a short canopy that you could walk in, and that's where there was just Parasitaxis everywhere. And so this is inside that little canopy created by that sinkhole.
And again, there have been research papers on, you know, on the role of a mycorrhizal symbiont in this plant, which, you know, is purported to, I mean, I guess it would make sense as Podocarpaceae is mycorrhizal, but it's such a weird plant. You know, I don't think anyone's ever seen this germinate or knows how it attaches to the host. And so the ones we saw were all coming out of the ground, but my friend Adam, who I was with, had been to that island 2 years prior and saw, you know, he saw this plant basically sprouting out of the stem of the host. So there's parasitaxis. And my hard drive's being slow. So
Thanks for showing that. That's cool.
I wish I got, you know, 40 more pictures to show, but my hard drive's, my hard drive's kind of crapping out. Here's some young ones just poking up out of the duff. Yeah, totally strange. Just super wet, super humid, super rich layer of duff. There you can see the falcatifolium seedlings. That's the host. But it's weird because, yeah, maybe in other areas of forest, like in one of the Araucaria humboldtensis populations, and you know, there was falcatifolium everywhere, but not a single parasitaxis. So it's really, you know, its occurrences are pretty odd and don't make much sense. I mean, we'd be in areas where just you'd assume it's everything. Santa Cruz. So it would have been cool to get this going, but you know, the most I've heard they can get up to 10 feet tall, 9 feet tall, but the most I ever saw them was like 3 feet. There's the cones right there. Just super cool color. And of course they're covered in this farina, this kind of white, blue, mealy wax. You know, probably to make them more attractive to birds. I assume they're bird dispersed. You know, there's no mammals on the island except for flying foxes, so. Yeah, I don't think my hard drive is going to let me share any more, but.
Does anybody have any questions for Joey? I was wondering what the industry on the island is. You said there was nothing really.
Yeah, it's all mining. It's all mining and tourism. It's all nickel mining and tourism. And some of the nickel mining is really taking a hit at some of the plants. You know, I mean, just I don't know. And then there's of course tension between the indigenous people, the Kanaks, and the French, and yeah, I don't know. I wasn't there for the culture mostly, but yeah, the main industries are tourism and nickel mining.
I got it. Yeah.
Are there national parks or national forests there? Did the French preserve anything?
There's trails. Yeah, I mean, a lot of the island is surprisingly not developed aside from the mines. You know, to get to most of these places, we had to hike. That's the other thing too. This is my friend. This is us hiking. They don't do switchbacks in New Caledonia. The trails just go straight up, and it's totally sketchy and totally dangerous and fun as hell. But brutal too, because of the humidity and the heat were so bad. And it's just I don't know why they don't do switchbacks, if it's to save space or what. But the trails erode pretty easily, and it was lots of that, lots of steep inclines. You know, basically I was wet with sweat or rain the entire time I was there. And we were lucky. We had a friend. He was a botanist there. He was actually going out of town for the 2 weeks that we were there with his family to New Zealand. So he let us crash at a spot. I don't know what we would have done otherwise. I mean, everything's so expensive. We kind of lucked out. You know, we got an air-conditioned, you know, nice house while we were there, you know, by a botanist, by like guy that's written a bunch of books on New Caledonia and Flora.
So there's no large animals. I mean, was that an animal-made trail rather than a human?
No, it was this hikers. It's like a popular hiking spot. It's a trail you could do, where that trail to the Paris of Texas. That's why we were surprised it was that easily accessible, but it was just a little bit off trail, and it's in this canopy created by these trees. And the only reason the trees are growing there is because there's a divot in the mountain where it kind of drops down a little bit, and they can grow up there. But and the Paris of Texas is just, you know, growing right there on the Falcatifolium. But and there's no reptiles either. There's no snakes. The only snakes are they get sea snakes, those deadly venomous sea kraits. And this guy right here, my friend Adam, he's a big herpetologist nerd. You know, I've heard you can handle the sea kraits. If they bite you, it's over. That's it. But they're just not used to encountering terrestrial predators, that they're super docile. And sure enough, our last day there, we went out to find some beautiful snake, bright blue, like sky blue, striped with black. And then, of course, the tail.
We missed it. We got the bright blue, striped black.
Pretty reckless, but pretty cool to watch too at the same time. So yeah, it's a weird island, man. It's been separated for a long time. You've got, you know, your kind of cosmopolitan tropical stuff at the lowlands, and then on the ultramafic areas, you've got all the really weird lineages of plants, and then all the Araucarias higher up on the mountains. Araucaria columnaris, that super common one, is the only Araucaria that grows at lower elevations. So lots of cool orchids too, lots of cool terrestrial orchids.
How high elevation is it, the highest point?
Highest point's probably 5,000 feet, not that tall. At least not by North American standards, so.
Okay. Anybody else have anything for Joey, or any questions, or speak up, or forever hold your peace? Thank you, Joey. That's very interesting and informative, and fascinating, different types of plant life in the different harsh environments.
Yeah, thanks a lot. Thanks a lot for having me. Wish I could have given it in person, but obviously, you know, we're in the middle of a pandemic, so hopefully you got something out of it.
We can't give you a standing ovation, sorry. Normally we clap loudly.
Well, thanks.
Here we go.
I'll clap for him. Just one clap here.
Thanks a lot.
Okay, thanks everybody. If anybody has any feedback on how to, you know, improve our meetings or whatever, please feel free to email calhortsociety@gmail.com. And I think that's it. Good night, everybody.